Welcome to Black Hole Basics. Today, we investigate the most controversial object in astronomy, a mysterious visitor from deep interstellar space. In October 2017, astronomers in Hawaii spotted a faint point of light moving rapidly across the dark, star-filled night sky. This object was not behaving like a normal rock. It was moving too fast to be bound by the sun's gravity. Calculations quickly confirmed that this object did not originate from our solar system. It had come from the vast space between stars. Astronomers named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first, fitting for our first interstellar guest. Humanity had never seen anything like this before. Every telescope on Earth quickly turned to track this fleeting visitor before it vanished. We only had a few weeks to observe it. As it retreated into the darkness, the data it left behind was puzzling. The brightness of the object changed by a factor of 10 as it spun, which was an extreme and unusual variation. This light curve suggested the object was extremely elongated, perhaps 10 times longer than it was wide, like a cosmic cigar. Most asteroids are round or potato-shaped. Oumuamua's extreme elongation was unlike any natural space rock we had ever seen before. Later analysis suggested it might not be a cigar, but rather a flat, pancake-like shape, which is equally rare in nature. Its surface was dark red, likely due to organic-rich tholins produced by long-term exposure to cosmic rays in interstellar space. It passed inside the orbit of Mercury, surviving intense heat, yet we saw no signs of a cometary tail or gas. Usually, when icy objects get close to the sun, they heat up and release gas, creating a visible tail called a coma. But Oumuamua showed no tail. The Spitzer Space Telescope looked for heat from dust, but found absolutely nothing around the object. If it was a comet, it was a very strange one. If it was an asteroid, its orbit made no sense. Then came the biggest shock. As Oumuamua moved away from the sun, it accelerated slightly faster than gravity alone could explain. This non-gravitational acceleration is common in comets due to outgassing, like a rocket thruster, but Oumuamua had no visible gas. Without visible jets of gas, what was pushing it? This anomaly sparked one of the most heated debates in modern astronomy. Avi Loeb, a top astronomer at Harvard, proposed a controversial hypothesis. He dared to ask if it could be artificial. Loeb suggested that Oumuamua might be a light sail, a piece of advanced technology pushed by the pressure of sunlight. Solar radiation pressure could explain the acceleration without gas. But for this to work, the object had to be incredibly thin. It would need to be less than a millimeter thick. Nature does not typically produce large, ultra-thin sheets of solid material. Could it be a defunct probe from an ancient civilization? Or perhaps a piece of space junk drifting through the galaxy? The media went wild with the alien theory, but extraordinary claims require extraordinary evidence, and many scientists remained very skeptical. Most of the scientific community looked for natural explanations. They wanted to solve the puzzle using the physics we already know. One leading theory was that Oumuamua was a hydrogen iceberg, formed in the freezing cold heart of a giant molecular cloud. Pure hydrogen gas would be invisible to our telescopes. This would explain the acceleration without a visible tail or coma. As the hydrogen evaporated, the object would wear down flat, just like a bar of soap used over many showers. However, critics argued that a hydrogen iceberg would likely evaporate completely during its long journey before ever reaching our solar system. Another strong contender was nitrogen ice. We know nitrogen ice exists on Pluto, so it is a familiar natural material. If a planet like Pluto was hit by an asteroid, shards of nitrogen ice could be ejected to become interstellar travelers. Nitrogen ice would also explain the non-gravitational acceleration while remaining invisible to our sensors, a very plausible natural solution. But Loeb argued that the statistical probability of us finding such a rare fragment as our first visitor is vanishingly small. For us to spot a nitrogen chunk by chance, every star would need to eject unbelievable amounts of mass into the galaxy. The debate continues because the object is gone. We cannot take samples or more photos. We are left with only mysteries. Even our most powerful new telescopes like James Webb cannot chase it down. Oumuamua has faded forever into the cosmic night. Some scientists have proposed Project Lyra, a daring mission to launch a high-speed spacecraft to catch up with the object. Using advanced propulsion and gravity assists, we might catch it by the year 2050, but it is expensive. Instead of chasing the old ghost, we are preparing to find new ones. The Vera Rubin Observatory will soon begin operations. It is expected to detect at least one interstellar object every year. We will move from a sample of one to many. We have already found a second visitor, Comet Borisov. Unlike Oumuamua, Borisov looked and behaved exactly like a normal comet. Borisov's normalcy makes Oumuamua's strangeness even more profound. It proves that not all interstellar visitors are built the same way. Whether natural or artificial, Oumuamua has taught us that our solar system is not an isolated island in the universe. We are constantly being bombarded by material from other stars. The galaxy is mixing its matter in a grand cosmic cycle. Oumuamua came from the direction of Vega, a bright star only 25 light-years away, but it didn't start there. It has likely been wandering the galaxy for hundreds of millions of years, passing countless stars before stumbling upon our own. Avi Loeb also identified a meteor that hit Earth in 2014 as a potential interstellar object, predating Oumuamua's discovery. His team went to the Pacific Ocean to retrieve fragments. They found tiny metallic spheres with unusual compositions not found on Earth. These spherules were rich in rare elements. While controversial, it shows our active desire to touch interstellar material with our hands. But back to Oumuamua. Its legacy is the open mind it forces upon us. We must be ready for the unexpected. A new generation of astronomers is being trained to look for anomalies, not just confirmation of what we already think we know. Planetary defense systems are now more alert than ever. We need to know if an incoming object is a rock or something else. If it was artificial, it was likely space junk, a dead piece of technology from a civilization that might no longer exist. This brings up the concept of space archaeology, searching for physical artifacts of other civilizations, rather than just their radio signals. We listen for radio signals from Oumuamua using the Green Bank telescope, but the object remained completely silent to our ears. The silence doesn't disprove the artificial theory. A piece of floating debris would not be broadcasting messages to us. Scientists are still refining their models. New papers are published every year trying to explain the acceleration with exotic physics. The concept of dark comets has emerged, objects that have enough ice to accelerate, but not enough to create a visible tail. Another theory suggests it was a fractal dust aggregate, a fluffy, ultra-light structure formed in the outer disk of a star. Such a structure would be pushed easily by sunlight, explaining the acceleration without needing to be an artificial solar sail. However, such a fragile object might not survive the harsh forces of interstellar travel or the tidal forces near our sun. The planetary fragment theory remains robust. It suggests Oumuamua is a piece of a shattered world, a cosmic survivor. Its red color matches objects in our own Kuiper belt. This hints that other solar systems have similar chemistry to ours. Our own solar system ejected trillions of comets in its youth. It is only logical that we eventually catch one returning. The technology to detect these faint intruders is improving. We are entering a golden age of time domain astronomy. The European Space Agency is launching the Comet Interceptor. It will park in space and wait to ambush a pristine target. If another Oumuamua appears, this mission could fly by and capture the high-resolution images we so desperately missed last time. Imagine seeing the surface of an object from another star system up close. It would be the holy grail of planetary science. Until then, the acceleration anomaly of Oumuamua remains its defining feature. It is the puzzle piece that doesn't quite fit. Its tumbling motion indicates it experienced a violent event in the past, perhaps the collision that ejected it from its home. It takes billions of years for such tumbling to stop naturally. This tells us Oumuamua has been traveling for a long time. Surprisingly, before it met the Sun, Oumuamua was moving very slowly relative to the average motion of nearby stars. It was like a buoy floating on the galactic ocean, and our solar system smashed into it at high speed. Loeb argues this specific velocity is suspicious. If you wanted to observe a galaxy, sitting still is a good strategy. However, astronomers counter that young stars also move at this speed. Oumuamua could simply be a piece of a young system. The discovery forced the International Astronomical Union to create a new category, I for interstellar. Oumuamua is number 1I. We now have a catalog of interstellar objects. It is a very short list, but it will grow rapidly this decade. Studying these objects allows us to analyze the building blocks of other solar systems without ever leaving our own backyard. Some scientists speculate about panspermia. Could objects like Oumuamua transport microbial life or organic material between the stars? Deep inside a rock, life could theoretically survive the journey. However, Oumuamua's surface was baked dry, making this unlikely. The visit of Oumuamua reminds us that Earth is not hermetically sealed. We are part of a larger, dynamic galactic ecosystem. Let's recap the three main anomalies: the extreme shape, the hyperbolic orbit, and the mysterious non-gravitational acceleration. While the scientific consensus leans heavily towards a natural explanation, the artificial hypothesis cannot be strictly ruled out with zero data. Science thrives on anomalies. If we dismiss the weird cases just because they don't fit our models, we learn nothing. Avi Loeb's persistence serves a purpose. It challenges the conservatism of science and pushes us to consider all possibilities. The legacy of Oumuamua is the alert state of global astronomy. We are now watching the sky with unprecedented vigilance. Artificial intelligence is now sifting through petabytes of data, looking for the telltale trajectory of the next interstellar visitor. It is only a matter of time. Perhaps tomorrow, perhaps next year, another messenger from afar will enter our system. And this time, we will be ready. We will have the cameras, the rockets, and the sensors to reveal its true nature. Imagine landing on an interstellar object, touching a rock that was born around a star that might have died eons ago. A single sample from such an object would tell us more about the galaxy's history than a century of distant observation. Oumuamua is now far beyond the orbit of Neptune, diving back into the eternal darkness of the interstellar void. It is heading towards the constellation Pegasus. It will travel in silence for millions of years before approaching another star. Will astronomers on a planet around a distant star one day spot it and wonder, just as we did? We are connected to the rest of the galaxy through these wandering rocks. They are the blood cells of the Milky Way. The question, are we alone, remains unanswered. But Oumuamua made us feel, for a brief moment, that the answer might be no. It taught us humility. We realized how little we know about what floats in the dark spaces between the stars. From a cigar-shaped oddity to a potential alien probe, the story of Oumuamua is a modern scientific thriller. Keep looking up. The universe is full of surprises, and the next great discovery could happen any night, right above you. If you enjoyed this deep dive into the interstellar mystery, check out our other videos on black holes and dark matter. Oumuamua has left the building, but the door it opened remains wide open for future explorers and dreamers alike. This has been a production of Black Hole Basics. We are dedicated to bringing the universe down to earth for you. Don't forget to hit the like button if you learned something new, and subscribe to join our community of space enthusiasts. We owe a debt of gratitude to the astronomers who work tirelessly every night to monitor our skies and keep us safe. The cosmos is vast, dark, and mostly empty, but it is the rare visitors that make the emptiness worth watching. Oumuamua. Remember the name. It was the first, but it certainly will not be the last messenger to arrive. Join us next time as we explore the Great Attractor, the mysterious gravitational force pulling our entire galaxy towards it. Until then, keep your eyes on the stars and your mind open to the infinite possibilities of our incredible universe. Science is a journey, not a destination. Thank you for walking this path of discovery with us today on this channel. For detailed sources and further reading on the Oumuamua mystery, please check the description box below this video. I'm your narrator, signing off. Stay curious, stay safe, and keep exploring the wonders of the cosmos. Goodbye for now. Thank you for watching Black Hole Basics. Subscribe for more cosmic mysteries as we continue to explore the unknown universe together.